Yeah, I think we're good. Yeah, but we're gonna start. Okay.
There's some banana folks that we're gonna try to attend. I don't know if they're,
Okay. Yeah, no worries. I can give them a
Excited
second.
to learn.
Cool.
That'd be great. You saw my three full slides. Very thick.
A lot of stuff is that kind of. Yeah. Yeah, God, no, you like it. I'm feeling that fighter. And then stay for that while. These terms Okay, we're gonna get ready to get started, everybody. I got 3 slides, and Damon's taking over. Why does it say view badge photos? Because I didn't take the time to actually check that out. But welcome to this monthly gathering. And some of us talked about this in the morning, but like, this is for you all. So as you desire new content, as you desire different things to be shifted around, we'll look at a kind of a peek for the future schedule. Let us know. We're a data-driven company. We want your feedback. We want this group to continue to grow, match talent to opportunity, and make sure that this is productive for you guys. And if it's not working and we need to do something else, we will. So just know that that's kind of our intent. And Leland is the star of the show here. You'll hear from the second. West 6th is where we're going after this. You can be here on Bezos, and we'll get you your first one. I'll expense that. You're welcome in advance. Hopefully it's a Coke, a beer, whatever you guys want. The last one we went to from here took forever to get a drink, so we switched it up to try and not have that happen. The ones in green are topics we've already covered, of course. Kubernetes is tonight. And then December is a roundtable. We'll have it at O'Shea's. We're gonna have some appetizers, drinks. It'll be more casual. And we have a couple of ideas. One is even having like a panel of our experts, but then an open chair. So if one of y'all want to sit and get asked questions on what you're building, or if you want to contribute, or any of those types of things. And we may have like a fishbowl where you can like submit anonymous questions or whatever, and like we'll answer them all, no matter how like curmudgeonly you all want to be, or how nice, or if there's a certain topic you want to talk about. We have these scheduled, but if there's other topics you want, we can shift this. So, you know, January, potentially data lake, February networking, Dan Powers, who some of you guys know, he was the TAM on Humana for a while. He's been promoted and shipped to do a couple of other things. VMware from Marshall. He's a technical account manager. So there's a bunch of different folks we have, and we also have resources that we can shift this around. So you'll get a survey at the end of this. We expect you to contribute, and then you should expect us to respond.
Do we have the date for December?
December 9th.
9th.
Mhm. And it's also on the MeetUp site. So, yeah. Anything else before we get started? Yeah. December 7th. December 7th.
I'm sorry, sure. December 7th, 1941.
Right.
Yeah, sorry about that. I did not do my one job.
So it is a week earlier, next month. We aim to have these, second Wednesday of the month, but with holidays coming up, they were already booked out, so we're a week earlier.
Cool. So, hey everybody, I'm Leland Johnson. I'm a senior SA at AWS. I've been, I think, to all of these, so seen a bunch of you around. Tonight, obviously, we're going to talk about Kubernetes on AWS. So just to let you know, I'm not going to go super deep into the nuts and bolts of Kubernetes. Kubernetes is what we call a very rich ecosystem, right? There could be hours and hours on everything. I'm not the guy for all of those, but there are many ways to run containers in AWS and several ways to run Kubernetes on AWS. So I'm going to give you an overview of those. I'll start with a little background on just high level set on what Kubernetes is and what it's for. I'm sure a lot of you already know, but just to make sure everyone starts from the same place, I won't spend a lot of time there, and then we'll just go over the things I just mentioned, like ways to run Kubernetes in AWS. That makes sense? So a quick survey, how many of you feel like you have at least a 100 level understanding of what Kubernetes is and what it's for? Okay. So several of you, so that's cool. That's good. Okay, no problem. It's all good. We'll cover all that. Let me first talk about containers and container services, because that's why Kubernetes matters, right? So just to level set, containers are a way to package up your code and their dependencies and a mini lightweight OS all together in one thing that you deploy in all of your environments, right? So we think back to how we did things before. You'd write code and you'd end up with some binaries that get put somewhere. There's some configuration files that get put somewhere. There's an OS that needs to be patched. There are other things that get installed on the machine. And all of those things have to come together for it to work, right? So those things may come together really well on your machine. And as soon as you deploy it to your test environment, it breaks, because even though it's the exact same binary maybe that you compiled, you may be missing some dependencies on that machine. And imagine that problem gets repeated over and over each environment you promote through, right? That's a problem that wastes a lot of time when it comes to troubleshooting. Just lots of, yeah, grab a seat anyway, guys. Basically, that's a pain in the neck, right? That way of doing things. Containers are kind of the answer to that, right? Once you've built your container image where you have all those things packaged, like everything from like this really skinny OS to the patches that go on it to any dependencies, your code, you get this thing. You can deploy that exact same thing in all of your environments, right? So you start from this known good state, no matter where you go. So that's the beauty of containers. But that's just what the container is. Ultimately, I'm talking way beyond my slides. I'll move through slides as we go, but I want to make sure we all have the same context. So that's just the container, your code and the dependencies that go with it. Now imagine a production workload where maybe you need to load balance several instances of that application, right? To serve your traffic, you need 5 of those running. Just by having that container, you're not solving that part of the problem. So you need a place to run all 5, to make sure all 5 are up all the time. If one dies, it'd be nice to have something that restarts it so that you always have 5 because you need 5. And by the way, on top of that, say you get a spike in traffic and now it takes 8 to service your application. It'd be cool if you had a system that could know that and scale out to 8, right? That's what that's one of the things a container orchestration platform does. And Kubernetes is definitely the most famous, most widely used container orchestration platform, right? So that's why we use Kubernetes. It's a way to take care of running our containers, making sure that the right number is available, monitor the health of the container and take action if it fails. It's a way to provide storage and other things to that container infrastructure. It's a way to provide DNS inside of a contained environment so that applications running in one container can discover the endpoint for another application that may also be running in a container somewhere, right? So that's the advantage of Kubernetes. Here, these are kind of like the business level advantages of running containers, and the same applies to Kubernetes, right? Packaging up all of those dependencies together so you have a known good thing that you're deploying everywhere helps you deploy faster, right? There's less troubleshooting, less figuring out what's wrong per environment. Reducing risk because your base images, you can scan those base images and know that, all right, this one's blessed by security. It's got all the patches they expect. It's running the versions they expect. That's your starting point. You put your code on top, you scan your code, you have, this thing that's the same thing that's running in your test environment and in production is that blessed thing that you've already vetted, right? That's a way to reduce risk. Quality, the same thing. I mean, I could repeat these over and over again. All of those benefits I named help enable all of these characteristics that are listed up here, right? So that's why containers matter. That's why containers are really popular right now. It's when we think about building and deploying cloud native applications, often containers is one approach. It's a very popular and common approach. So running containers in AWS. So obviously we have more than one way to do it. Tonight we'll focus on Kubernetes, but I want to make sure you guys have an understanding that there are many ways to do it. So for application networking, so this is for your applications running in a container to understand how to talk to each other, adding policies to control who can talk to who, how they discover the endpoint for another. That layer here, we have a couple of services, so a Cloud Map and App Mesh. The next layer down, this is the layer where Kubernetes lives, so what we call an orchestration platform or container management. We have ECS, which predates Kubernetes, but it's still a very viable AWS offering, right? We put a lot of effort into supporting it still. Just because it's older, don't write it off. Lots of our customers use ECS. And in many ways, it's simpler than EKS. Right? There are reasons to use EKS, our Kubernetes offering, as opposed to ECS. But there are also very good reasons why ECS may make sense for you, right? So don't default to Kubernetes just because it's the new sexy. Right? And we may do another session in the future to talk about ECS if that's something you guys are interested in. The next layer down, like the hosting, the compute layer, right? So a Kubernetes cluster is made up ultimately of machines, something that provides compute. We have EC2, which is, I'm sure most of you are familiar with. It's our VM-like environment, providing instances to the underlying Kubernetes cluster. We also have Fargate, which is our serverless version of that. So think of Fargate as just putting out a request saying, I need a machine that's roughly this size, no other details. You don't have to care about the care and feeding of that machine, patching, bring it up. Fargate will provide you a place to run your container with very little administration from you, right? So that's, Fargate's a very interesting offering and it complements Kubernetes really well. Both EC2 and Fargate complement Kubernetes really well. We'll talk a little bit about that more later. And then finally, I mentioned before, so how you build a container and then you put it somewhere and then you deploy that image all over the place. Well, where's that place that you put the container? That's a container registry, right? Every cloud provider that has a way to run Kubernetes has a place for you to store your container images because it's peanut butter and jelly, right? You can't really do it without it. We have our Elastic Container Registry for that capability. Any questions so far? Yep. Don't ask me a hard question. No. Yeah.
I think it's really important to include in this app run.
Oh,
You should really-
yeah, you're right. This is probably because this deck is slightly dated, but you're right. That's a
So app runner is kind of like a go-between, where you think of it as managing and hosting your containers or your containers. And so you don't have to think about clusters, zero Kubernetes. It's another offering, newer offering that all you think about is your Docker. Well, a lot of things.
yeah. That's an awesome point, and it's a point I'll probably make a couple times tonight. Of course, we're focusing on Kubernetes, but if you imagine a spectrum between all of the ways to run a container in AWS, right? So you have EKS on one end, which is awesome and does lots of things that nothing else does, but it probably takes a little more administrative effort than some of the other offerings. You can imagine ECS in the middle, which does some large portion of what EKS does, but not everything, but it's easier to administer. And then there's App Runner at the other end where the least amount of administration, but it doesn't necessarily do everything that those do. So as you explore which services to use, keep that spectrum in your mind and understand that you don't always have to default to one end or the other. Weigh them against your use case. Obviously, EKS gets a ton of usage, and so does ECS, right? So this slide has really tiny text on it. You guys might have better vision than me. Yeah, I should have taken it out. But basically, this is kind of an overview of the things I just talked through. All the services that relate to running containers on AWS, bucketed into their category. So the high-level capabilities and the individual services before. I called out the ones that I think are super relevant, like ECS, EKS, Fargate, added App Runner. This is easy to find online, so I won't read through all the details. My vision's not up for it anyway. Okay, so now that we understand containers and container orchestration, we're going to talk about EKS, which is the AWS implementation of Kubernetes in the AWS cloud. I thought I had a slide that explained this better. I'll talk about it here. So basically, a Kubernetes cluster is made up of two areas that you need to manage. There's the control plane, which is where API calls to manage the cluster, the care and feeding of the cluster, that tier happens there. And there's what we call the data plane, which is where your workloads run, right? Your containers that you deploy. So if you imagine that partition between the two, the control plane and the data plane, what part of what you get with EKS is that AWS manages the control plane for you. So there are pieces, and we'll show them later, that make up that control plane, right? So there's a service that stores state, etcd. There's a service that handles DNS, like endpoint discovery within your Kubernetes cluster. All of those things are part of the control plane, and the AWS takes it on themselves to manage the availability of those components of the control plane and provision those. So if you go in the console and stand up an EKS cluster, you're not going in there and saying, I need this many control plane nodes and I want to run, put this version of etcd here and all that. You just say, I need a cluster. And all that stuff is handled behind the scenes by AWS. So the building a highly available control plane is handled on your behalf, right? The tier down, what we show down here, like with the availability zone 1, 2, and 3, that's where your work runs, the data plane where your applications run. And the typical EKS cluster within AWS, you're dividing your containers across availability zones. And as a refresher for those of you who may not know, the AWS global infrastructure is divided into regions, right? So a region will be a geographic area that has several data centers in it, right? Those data centers are separated by I forgot the number of kilometers, but they're separated enough to make them fail independently in most cases, right? Like, well, in every case, right? If one floods, the other one is very, very unlikely to be affected by the same flood, or tornadoes not likely to hit both of them in an availability zone. So our regions are divided into these availability zones, and they're our fundamental way to provide high availability. So that you can, most things in AWS, you can lose an availability zone, but your application continues to run because most of our services understand this concept of an availability zone and makes it easy for you to provision your workload across these zones, right? And the same is true for EKS. So when you're building an EKS cluster, you can assign subnets that belong to particular availability zones so that your work is spread across these. So you can lose one, and theoretically, your business isn't impacted, even though you lost some portion of your cluster, right? That's for the data plane layer. Like I said before, the control plane layer, where that actually manages the cluster, the same infrastructure applies, but it's pretty much invisible to you. AWS handles that for you, right? So the place where when you're typing command line controls to change the configuration of your cluster, or the thing that monitors the cluster to know if it should deploy more containers, all that runs in the control plane, and that's managed by AWS. Okay. This is the point I just talked through, the control plane architecture, just to drive the point home. In the control plane, there are more components than this to the Kubernetes control plane, but some of the important components here, I mentioned etcd. Etcd is a place where the state is stored. That's handled in the control plane, and that's managed by AWS. Trying to think if there's anything else I need to talk about here. This slide is out of date. I thought I deleted it, but it helps me talk about a particular point. So you can see here, it mentions 3 supported versions and then these several deprecated versions. We actually now support 4 versions. The current best version and the 3 previous versions before we deprecate them in AWS. And that allows you to upgrade your clusters at your own rate, right? That, everyone knows it's bad news when you're behind and then your cloud provider says, hey, you've got to update by X date, and all hands on deck. It happens from time to time. It's a pain. We try to ease that pain by supporting 4 versions at a time, right? Unlike this slide says 3, it originally was 3, now it's 4. So 4 versions at a time of EKS are supported, just to make it easier for you to manage upgrading. Architecture slide. These are some, actually, these are some of the compliance standards that are met by running EKS in the recommended way in AWS, right? Of course, not to oversimplify these points, a lot of these standards, there's a portion for the cloud provider to do and a portion for you to do as the customer. But what we're saying is here that we know clearly how to meet all of these requirements. And I think FedRAMP is actually met now too. So this coming soon we can double check on that, but I think FedRAMP is also included now. But if you need to build a HIPAA compliant environment, for example, we're certain you can do that with EKS in AWS, and we can guide you on how to do that if that's a requirement you have. Humana. So now talking about the data plane, and like I said before, this is the part of the cluster where your workload runs. When you deploy your containers, they're running in the tier that we call the data plane. And basically, there are these 3 ways to provide compute resources to the data plane. So there's bring your own EC2 nodes. So you can go into the EC2 console, say I need to spin up 10 instances running this particular OS. You make some changes to those and you make them available to EKS to be part of your Kubernetes cluster. That's possible. That's not the preferred way. There are reasons to do that if you have very specific needs about what needs to run on those nodes. But in general, that's not the place where I would start if you need to run Kubernetes in AWS and you need to give the cluster compute. The place I would start are these other 2. So either manage node groups, which is a abstraction in AWS where you tell EKS to give me some EC2 and provide it to my Kubernetes cluster. What that does for you, the provisioning, some of the things that have to be done to provision a node for your Kubernetes cluster is handled automatically through that step, right? Upgrading is easier. So when the Kubernetes agent needs to be upgraded, that's much easier when you're using managed node groups as opposed to bring your own EC2 nodes. And then over here on the right, the easiest of them all is Fargate. And Fargate is our service for running containers. So if you imagine the other two where you have a node, and let's equate a node basically to a VM, right? So there's a VM in your cluster. Kubernetes understands the capacity of that node and how many containers it could possibly run on there, right? So there's some math, and it figures out the most efficient way to use the instances available to your cluster. And it puts several containers on a particular instance. Fargate is different in that when there's a need for another container to be scheduled in the Kubernetes cluster, Fargate just provides basically a VM that's big enough, and VM's the best way to think about it. It's not exactly like a VM, but Fargate provides an instance for that one container to run on, right? And that instance is not shared across containers, right? So you only get one, unless there's some configuration options, like some patterns where you describe running two containers together. But in general, it's a one-to-one correlation between the container and Fargate. For those of you who are more familiar with Kubernetes, it's a one-to-one to a pod to a Fargate instance, right? So a pod may have more than one container in it. That pod will be deployed to a single Fargate instance. The advantage there is that there's very little administration and care and feeding for you to do of a Fargate instance. The agent that's required to run it, understanding the health of it, making sure it's added to the cluster, none of that, you don't have to worry about any of that. You just say, I want this pod to run in Fargate, and you're basically done describing what needs to be done. And Fargate and the EKS service provide compute to run that pod. When that pod dies, when that pod goes away, that Fargate instance goes away too. Whereas unlike the other two, the nodes that are running in EC2, the pod can go away, but that instance is still there waiting for a pod to be scheduled on it. These Fargate instances are tied very closely to the lifecycle of a pod. I won't beat this to death, right? I've already kind of talked about a lot of these, but one thing I'll mention about why EKS makes sense, because before there was an EKS available, we had lots of customers running Kubernetes clusters in AWS just on EC2, right? You could go in, spin up some instances, install all the components you need, and you're running Kubernetes. In fact, lots and lots of customers in the early days did that. They were running Kubernetes on EC2. Some of the advantages to EKS, though, because it's a AWS managed service, you get AWS testing of all the dependencies that go into making a Kubernetes cluster, right? So I mentioned there's like that core DNS service that provides name and endpoint resolution within the cluster. That's actually a component that's deployed with most Kubernetes clusters, but it's not part of the Kubernetes project. It's its own open source project. So imagine that's a project with its own life cycle. There's Kubernetes is a project with its own life cycle. etcd is also a separate open source project, but it's important to Kubernetes. So it's got its own life cycle, versions that change at their own rate. Kubernetes changes. So managing that on your own, understanding that this version of core DNS and this version of etcd and this version of Kubernetes, they play together well for my use case. That's a lot of work, right? So in general, in this day and age, you would want your cloud provider to give you some help there. And part of that help is EKS. So EKS, and I'll talk later about EKS distro, which takes this to another level. But part of the advantage of EKS is that AWS has already done that work for you. And we've tested it, a lot ourselves, and it gets tested across all the AWS customers who are also running EKS, right? So you don't have to worry about that understanding. If I patch core DNS, is it going to break something else in my cluster? All that's managed for you because you're running EKS, our managed version. There's also integration with other AWS services, right? So running containers in your cluster, your application and the nodes themselves are spitting out logs all the time. There are plenty of ways that are well documented how to get those logs out somewhere where you can see them, right? But there's, like everything, there's 10 ways to solve that problem. And you can solve them you can use any way you choose with EKS in AWS, but you also get native integration with our log aggregation tool, CloudWatch, right? So all of your logs can end up in CloudWatch. You can set alarms on those logs to notify you when certain things are happening in your cluster. with no extra setup, right? You don't have to do anything to install an additional agent here, to configure where those logs go. You just get that kind of integration natively because you're using EKS, as opposed to roll your own Kubernetes in AWS. And on, right? EKS understands networking within AWS, so it's easier to provision the networking components required to make your cluster run well. Same is true for load balancing between your nodes. So there are lots of advantages to using EKS as opposed to roll your own Kubernetes. At the end of the day, you still get a Kubernetes service, right? It's important to note that EKS is Kubernetes. It's not a AWS version of Kubernetes. It is the same Kubernetes that's running everywhere else, right? It is Kubernetes, but we add these extra things to make it easier to manage the dependencies and to integrate with the AWS cloud, right? This is another architecture kind of point, but basically, what we're saying here is the point I just made. It's vanilla Kubernetes, right? It's compatible with Kubernetes everywhere else. The things that you would do to describe how your workload runs in EKS, those will work everywhere else for the most part. I mean, there might be subtle configuration annotations that might be specific to AWS, but the important parts of your configuration are generic Kubernetes things. You could learn how to run EKS by reading the Kubernetes documentation on the Kubernetes project site. And there'd only be a very small number of things that you'd have to understand in an AWS specific way. So now that's Kubernetes, managed Kubernetes EKS in AWS, but we also have a couple other ways to run Kubernetes that are where you still get the benefits and the help from AWS. One of them here, we mentioned Outpost. So Outpost, for you guys who don't know, it's our hardware offering, right? So you get a rack of compute and storage. You put it in your data center, you hook it up the way we tell you, and you get a little piece of the AWS cloud in your data center, right? So you get EC2, you get S3, you get storage volumes, and you can run EKS there, right? So through your AWS console, where you look in and you see US East 1, you see US West 2, you'll also see your local zone. You can see your data center show up. And some of the services that are available in the cloud, not all of them, but some of the services that are available in the cloud are also available locally in your data center. EKS happens to be one of those services. There's also, I have another slide where I'll talk through the point I was about to make, but one thing I'll point out here, and I've kind of alluded to it a little bit, but it's an important concept whenever we talk about services in AWS, is our shared responsibility model, right? So if you talk to anyone from AWS for more than 15 minutes, the conversation probably drifted to something that hinted at the shared responsibility model. And what we mean by shared responsibility model is that there are certain components, certain aspects that AWS manages on your behalf, no matter what service it is, right? So physical security of our data centers, right? When you're running an AWS, obviously you don't have to care about the physical security of the data center. We're doing that for you. Patching, network security, all of those things fall on the responsibility of AWS. And depending on the service, there are other things that are your responsibility. For example, you stood up an EC2 instance, you installed your own OS image, you're responsible for patching that image, right? We're responsible for the physical hardware. If a hard drive fails or whatever, we're responsible for making that work for you, but you may own the OS there. So in that example of EC2, patching of the OS belongs to you. That's your side of the responsibility. Having a physical machine that's not on fire and connected to the network is AWS's responsibility. When it comes to any service, that line is in a different place depending on the service, right? So with EKS, the physical nodes that make up the cluster, the availability of the control plane, the software that runs in the control plane, that's on the AWS side of the line. Building your container images, making sure that you're using a base image that meets your security requirements, writing the code and deploying it, that's your responsibility, right? The line is there. With Fargate, right, everything related to the compute that runs your application belongs to AWS, and it's just deploying that belongs to you. So these lines here, when they show what's the responsibility of AWS versus responsibility of the customer, imagine a matrix like that for pretty much every AWS service. We can describe where your responsibility ends and where AWS's responsibility picks up. All right, so this is the point I wanted to make before. So there are a couple other ways to run Kubernetes with AWS help. The first of them is EKS distro. So remember that problem I described where there's Kubernetes, right? And it's well understood. It's a hugely successful open source project. Google has a way to run Kubernetes. Azure has a way to run Kubernetes. You can run Kubernetes yourself on your own hardware. But managing all those dependencies like etcd, core DNS, and all the other many things that could make up a Kubernetes cluster, understanding those versions and make sure they work together and the care and feeding of all those, that's a lot of work. We've solved some of that for you with what we call the EKS distro. So what that is the same distribution of Kubernetes and the dependencies related to Kubernetes that run in the AWS cloud and EKS. You can download that and run it on your own hardware. And it's the same version that's tested by AWS. In fact, along with the files you need to actually, with the binaries, if you want to install it, you could download the source code and the environment variables and everything you need to build it yourself, right? So you can download the repo and build it and deploy it wherever you want. And you're getting the same things that you would be running on the AWS cloud and run it wherever you choose to run it, right? The advantage there, it just helps you with that understanding of the testing. Have all the patches been applied to this version? Have these things been tested together? That solves that problem for you if you're bent on running it on your own hardware somewhere. And sometimes there's a good reason to do that. The other way we have is EKS Anywhere. And that's a step up from there. And what that is, it's a way to run EKS on your own hardware. So EKS distro is just think of it as a software package, right? It's just like there are different Linux distros, right? This is another distro of Kubernetes that's managed by AWS, but EKS Anywhere is actually EKS running on your own hardware. So you download EKS Anywhere, you point it at some hardware that belongs to you, either a VMware cluster or bare metal, and it installs EKS. If you choose, you can connect it to the AWS console. You log into AWS console and pull it up, and you see your EKS clusters running in the cloud and your cluster running on your own hardware in your data center, on your desktop, wherever, right? So you get the advantage of EKS, but running wherever, anywhere, like they say here, right? So one of the good use cases for that, like lots of companies, they're living in this place where they have plenty of things in their data center, some things in the cloud. They may be moving to the cloud, or they may plan on running that way forever, right? Running in both places. EKS Anywhere gives you a way to kind of simplify so that at least when it comes to your Kubernetes, you're running the same thing everywhere. So the same things you do to build your images, the same configuration options that you chose for the most part, you can apply those in your data center and you can apply those in the cloud. So aside from running EKS purely in AWS, you also have these other offerings to varying degrees. They help you run, they simplify running Kubernetes for you, right? How many of you are at a place that are running Kubernetes right now, like have Kubernetes in your environment? Cool. Awesome. And where are you guys at? Which company, if you want to say?
Del Toro.
Humana, okay. Humana, Del Toro. Okay. So, kind of talk through EKS distro, so I'm not going to go through a lot of these slides, but basically it's the core point I mentioned before. EKS distro is Kubernetes. It's special in the sense that AWS has done some of the heavy lifting for you as far as testing dependencies, security patching, making sure all these things work together, but it's still Kubernetes, just like any other Kubernetes. You could get the exact same experience if you wanted to by just downloading open source Kubernetes from the project and doing it on your own. But the advantage of EKS distro is that AWS has done a lot of that work for you, right? So if you've got infinite resources and infinite time, do what you want, right? But I don't think anybody has that, right? So anything that makes it easier, I think is the advantage. Make sure there's not a point on here that I should make that I'm missing. Yeah, I think I mentioned this before, but just to prove the point that it is Kubernetes, this last point here, that you could reproduce these builds on your own. You could just go out to the repo, download it. set the environment variables the way we describe in the documentation, and you built a version of EKS distro that you could deploy. So that's proving like, the truth of what we're saying. It is Kubernetes, and it's all open source for you to have access to. So yeah, let's talk a little bit about what's not included in the EKS distro. So what's included, I beat this point to death. It's compatible. It's upstream Kubernetes compatible. It is Kubernetes. You get core DNS, which is, as far as I know, the most common way to do DNS within the cluster. There are other ways, right? But it's a very common way. You get etcd, which is another core component. Things that aren't included, right? So EKS Cuddle, which is our command line tool for managing EKS clusters. It's not included, but it doesn't mean you can't manage them. It's just you don't necessarily use that particular tool to do it. Same thing, some of these AWS plugins. And the reason why these plugins aren't included is because these plugins are AWS specific, right? So they conform to an interface that is compatible with Kubernetes, right? Part of the Kubernetes project describes all of these interfaces that cloud providers should conform to so that their infrastructure works with Kubernetes, right? These are components that conform to that interface, but behind them, they're for interacting with AWS infrastructure. So it doesn't really make sense for them to be part of EKSD because you're running it on something that's not AWS. I'm just thinking if there's anything else that needs to be pointed out here. All right, I won't read through this, but and you can look at this. I think you can find this in the documentation pretty easily, but just to show what it takes to set up an EKS distro image, right? This is using a tool called KOps, which is a tool for simplifying the deploying of clusters. You don't have to use KOps, although it's all over the documentation, so it's probably the recommended way, but it's fairly simple. It looks very similar to what you do if you were doing this in the command line against the cloud, but within a few commands, you end up with an EKS cluster, which is running Kubernetes on your infrastructure. Yeah, so the key takeaway here is like, this isn't pages and pages of install this dependency and then this dependency and then edit this config file and then do this here and then run this command and then do that, right? It's not that. It's a very simple and direct way to get EKS distro running if you decide you want to run EKS distro.
Question?
Yep.
What's the dark blue text? That's a little hard to see.
Very good question. Oh, so this is just creating a config file on the fly and then passing it into the command. So it's creating it's deploying the IAM authenticator to this here is mentioning the IAM authenticator is deploying it into a namespace called kube system, some stuff, but basically it's just piping that text into a file that's passed into the. Yep. That's a good question. I haven't used KOps myself, right? So I've seen it in the documentation, but I'm sure there is, but I couldn't tell you to what degree there's a difference. But if you go through, so if you were to pull up the AWS blog that describes using EKS distro, I'm pretty sure it points you to KOps as a simple way. And the KOps installation looks pretty simple too. So yeah. But yeah, if you have constraints in your environment where you can't just download and install software, then you probably need to look at another way. And that's a place where you just lean on at Humana, you call this guy and he'll get you the answers on how to make that happen. Yeah. What's your question?
Is where you would recommend an EKS distro versus an EC2. Can you cite an example? How would we know which to use?
Yeah, so in general, if you don't have I'd start with, if you don't have a clear reason why you need to run EKS in your environment, we just know we need to run some containers and we need this app to run. I would start at EKS in the cloud, right? Just because we do a lot more for you there, right? So in the cloud, ideally in AWS, but even if it's not AWS, if you have, I know Humana has more than one cloud provider, regardless, look at your cloud provider as the place to run Kubernetes as your starting point. Then if you have some requirement, like your workload needs to be very close to some data that lives on-prem, right? Maybe you're talking to DB2 in the mainframe or something, or that kind of thing, then you may want to run a cluster in your data center that's close, so there's low latency to talk to your to that data that's on-prem. That might be a good use case. Also, we've seen some telecom providers and retail sites that want a Kubernetes cluster. They need to run it in remote sites. So they would install it in machines in a cell tower, or maybe in the back of a restaurant or a retail location. Those are the kind of use cases. But in general, like my starting assumption is that the cloud is the right place, and I'll look for a reason to dislodge that assumption as opposed to the other way around. Maybe that's my bias, but that's where I start. Yeah.
We see it in manufacturing mostly, right? In manufacturing, when the machines need to have the information in real time, really fast, and we move it really close. But not really a way to solve a latency issue when we talk about certain scenarios, especially when we're talking about manufacturing. When they build a blob to build a device, it has to be there when it needs it. Anytime that it delays puts the sequence of manufacturing out. So that starts at anything that's heavily sequenced, and it has to be in a linear fashion, very fast. You have to move that compute as close as we can. So there are some scenarios around that it does make a lot of sense to get there. And also, anytime that the infrastructure of the outlying area is weaker than it needs to be, right? Can I get the data set where it needs to be in an amount of time for that scenario? Sometimes when we get to very rural areas, very old factories, very old businesses, sometimes there's a distance problem, right? So new technology.
We had a customer who was migrating to the cloud, and they had a whole bunch of stuff that they were going to just let die on-prem. They put a cluster on-prem, and they had most of everything else out there, and then they interface those two. And their idea was just, once we replace those interfaces out in the cloud, we'll just let this stuff die on site once it retires.
Yep.
It very well can be workload specific, right? So
That makes sense.
Yes.
All right, so I talked a little about EKS Anywhere. We'll talk a little bit more about it here. Yeah, so EKS Anywhere is basically EKS on your own infrastructure, but unlike EKS distro, there's still a piece that's managed by AWS. You manage it through the AWS console if you choose. You don't have to use the AWS console, although you get that experience where you pull up the screen. I don't think I have a screenshot of it. You pull up the screen, you see your clusters in the cloud, and you see your clusters that are running on-prem, so you can manage them that way, right? You get all the benefits of EKS, or most of the benefits of EKS, but it runs in, like we just talked about. So in the question you just mentioned before, like, so there's that question, do I use EKS distro or do I use EKS Anywhere? Well, EKS distro, you're just getting software, right? And some support from AWS, but it's not the same kind of support. You get EKS Anywhere, which is a service, right? Yeah, the same applies to what I said before. It is EKS, it is Kubernetes, right? It's you don't have to worry about it being something special and different. The only changes are behind the interfaces that are designed into Kubernetes for the cloud provider to make their own changes. It's still fully Kubernetes compatible. And the choices you have right now, running it on bare metal or on top of VMware. Originally, this asterisk here, let me make sure there's no note. Yeah, originally it was VMware only, but now we support bare metal. So you can, depending on your requirements there, your compute can be provided by either of those two providers, and then you deploy your cluster on top of that. One thing they mentioned here, Flux. Flux is like a GitOps plugin. It allows you to manage and deploy your cluster using GitHub, or or in the same way you would do your any other infrastructure as code thing. You check in your changes, your descriptions into a code repo, and Flux will monitor that and then apply the changes to your running cluster, right? So I just saw that in there. I thought I'd call that out. That we could probably, maybe a future meetup topic on GitOps. It might be something that's interesting for you folks who are really looking to automate your Kubernetes infrastructure. We'll slide on GitOps. I'm gonna go too deep here because it's I just described it, but it's basically that, like it's bringing the experience that developers are very used to, where you write your code, you make your changes, you merge it into some repo, it gets blessed by the systems and the people who are in charge, and it ends up in some place that makes a build that ends up in lower environments and gets promoted up to prod. The same kind of concept can be applied to the configuration of your Kubernetes cluster and the workloads that run in your Kubernetes cluster, right? So you're making your manifest files, you have those changes, they get looked at and blessed and checked into some repo somewhere. Some human being looks at it and blesses it, and it gets promoted, and eventually that change automatically happens in your cluster, right? So it's a way to add velocity and take a lot of the manual human steps out of managing your cluster. GitOps is the new fanciness, and there are a couple ways to do it. We mentioned Flux here. There are others, but you'll find Flux mentioned in a lot of the AWS documentation.
Question.
Yep.
If people aren't using Git, how are they tracking their changes? What's the alternative?
I don't know what I don't know if there's a recommended alternative. Like ideally, yeah, you should be, because all these things are describable in these files that like describe, the state of how you want your system to be. Checking them into some repo makes perfect sense. I don't know. Yeah, I don't know if there's, I don't know if anyone else has an opinion or have seen other ways to do it. Only places where
I've seen a scenario where someone still wants to have configuration, config files, and YAMLs in Git, but they pull everything locally, and then we'll have local access to their cluster, and we'll make changes manually. Whereas in the GitOps world, you have pipelines for everything, right? So you'll have like more event driven instead of you actually saying, this local file that I have in Git, I'm going to now update your cluster.
Yeah.
But everyone hopefully does use some kind of version.
Yeah. Do you see that the way you described, is that maybe like a milestone towards moving towards GitOps in the future, or that they just had some requirement why they would do it that way?
Some knowledge gaps. I have seen a valid use case where it's like they had to wait on some corporate account to get them a Bastion host.
Yeah.
And to hook that up with their pipeline. So they had to do more manual steps, but
yep.
Lots of ways to not do this.
Yeah. Right. Yeah, so this is a little comparison between EKS Anywhere and EKS distro. I wish I would have had this slide earlier. I talked through all these points, but the picture makes it a little clearer, right? So EKS Anywhere, EKS in the cloud, and EKS distro, they all use EKS distro as the software you're deploying. But there's these, the big difference here is where it's running and then what it's running on. On-prem, it would be VMware or bare metal. In the cloud, you have those options, Fargate, or a couple of ways of running it in EC2. Oh, here's the screenshot I thought I had before. It's a very small one, but this is showing the AWS console, and in here you see. So if you look at the environment column, these are 3 clusters. One of them says local, right, and the other 2 are AWS or whatever. My vision's not good enough to read them, but basically, you're seeing both all of your clusters that you've deployed to your infrastructure and the clusters in the cloud. This is also just a picture depiction of what I described as like your options for compute underneath your cluster. Outposts, like I mentioned early on, that's our rack that you can deploy in your data center, where you get some piece of AWS, but it's running in your data center. That works really well with the use case Sean mentioned for manufacturing. Like we see a lot of manufacturing customers that are really interested in Outposts. So they can do things like run an EKS cluster, have some storage, have EC2 instances, but it's in their data center, like next to their near their data and near their manufacturing processes, so that they don't have to deal with that latency.
Can you mind talking about scenarios where you would use Fargate? What are the limitations there? Why you would
Yeah, so one thing with Fargate, like I mentioned before, it's basically a Fargate instance per pod. So there are scenarios where I can see the cost going up really high if you're running lots and lots of pods. Whereas with running it on EC2, you get that, you know, the natural bin packing that comes with Kubernetes, where you'll get multiple pods on a node on a machine, based on how the algorithm thinks if there's enough capacity for that machine. So theoretically, you can use less actual compute to run a workload if you've sized your nodes properly. Fargate makes a lot of sense when you're really concerned about management overhead and you may have some spiky workloads. There's also a fairly new offering called Carpenter, which is an AWS project, which kind of replaces the way the pod scheduler in Kubernetes works to decide, like, so where should I send this container to run? It bypasses some of the abstractions that are part of the way Kubernetes understands how to do that, and goes straight to the EC2 layer. So you can do things like workloads that spike up really high for a very short time and then go back down to some more normal state. Carpenter is a way to understand that and provide the right size compute for that, and then scale back down quickly, right? But in general, it has to do with, like, I'd say if costs were no option, it's always, cost always matters, right? Lean towards Fargate unless there's a reason not to. But honestly, when you're looking at lots and lots of pods, I would think about EC2. And there's also some other limitations, like if you have special agents that need to run in your nodes, right? Like you have some security requirement or whatever, but you need something else to run on those physical nodes that make up your cluster. You can't really do that in Fargate, but you can do that in EC2. So that's another reason why you may look at EC2 to back your cluster. Trying to think if there's
Silicon.
What's
You
that?
have like GPU workloads.
Oh, thank you.
You're going to be able to specify that on your EC2, so you won't be in Fargate.
Yeah. Yeah. Cool.
With Frank for making any choices, it's fine or reinvent.
Yeah, you never know.
Who was going to reinvent here? Maybe y'all can connect.
Quick question.
Yeah, yeah.
Can you go back to the first slide where you said it will support 4 versions at the time? What does that really mean? At that time,
Yeah, so, you know, there are constantly releases of Kubernetes coming out, right? To be officially, so AWS will officially support 4 versions, the current newly G8 version, and then the 3 previous ones. Whereas, you know, and every cloud provider probably has their own standard of how many they'll support. We can't support them infinitely into the past, right? But it's just a matter of like which version. Once you're, you know, at that the 4th oldest version, then you have to update your cluster, right? And there's tooling to make that easy. But yeah.
Something more about add-on configurations like backup, service mesh, like STO, Monero, Kubernetes.
Yeah, so definitely. So we have our own. I had a slide on that. So it's like service mesh. We have, of course, you can run SDO. SDO is really popular. We also have. Let me find the slide where we were talking about it. Yeah. So there's Cloud Map and App Mesh. It's like there are offerings in that tier, but you may consider, like, so if you may consider Istio in an environment like Humana, where you may be running Kubernetes clusters on-prem in AWS and Azure and GCP, right? So App Mesh makes sense in AWS, but there's no App Mesh in GCP, for example. So you may consider Istio there, and you can do the same thing. You can run Istio everywhere and have like the same tooling in every environment you run in, right? But that's a place where lean on Nick. You can get the specialist to talk to you about making that decision specifically, like against some concrete requirements. But
So I work with a customer where we have EKS clusters and AKS clusters. And so we had looked at STO and looked at Cilium cluster mesh. So those were two options that we considered.
Oh, but monitoring.
yeah, the same thing. So we, easy integration into CloudWatch. There's also, we have our managed Prometheus and Grafana, right? So if you wanted to output logs to those, or any other third-party provider, there's fairly well documented ways to get your logs out of your cluster into anything you want to send it to, but those are options, right? CloudWatch is the easy starting point if you're running in AWS, but lots of people use Prometheus and Grafana for that use case when they're running it.
You have to drop that in S3 and drop down.
Yeah, Dynatrace, it's been a while. I mean, I've been at companies that had Dynatrace. My knowledge is probably out of date there. I know when it looks, some of those tools, you have to be very careful with how they understand licensing in the cloud. Like, if you have a cluster that may scale up from 50 nodes to 500 nodes, like, does their licensing model work in a way that makes that easy for you? And I don't know the answer to that, but those are the kind of things I instantly start thinking about when people mention something like Dynatrace or AppDynamics or some other tool like that. Lots of them do understand the cloud, right? And they've solved that problem, but that's definitely a question you want to ask if you're considering that for your monitoring your cloud workloads.
When the versions change, is you talk about deprecating versions for some reason, there's some maintenance burden to you. Is that really only pertinent to, you said there were those plugins that were cloud provider specific? Wasn't those is there anything else besides those plugins and maintaining them? If there are API changes that is in your department of responsibility when a version changes that would make you want to deprecate them, or integration with the CloudWatch, or like why does Amazon care how many old versions it supports? Is it just the plugins or something else?
Well, I think it's just a matter of like, we have to maintain your documentation and knowledge, and also older versions tend to have, you're less secure when you're running on older versions, right? So it's also a way to nudge you into a more secure state, because the assumption is that newer software, once it gets over its honeymoon hiccup period, it tends to be more secure than older software. That's like a base assumption.
There's a risk profile that goes with the older versions. So the longer it runs, the longer there's a documented vulnerability. Log4j just for reference, right? So the longer you live and the older it is, the more that is looked at and documented as a documented vulnerability. Not saying that the newer versions don't have vulnerabilities.
They're secure through security.
They're secure through security.
And not to mention AWS and Google and Microsoft and all of, and countless unnameable others are contributing to the Kubernetes project, right? So they're bringing new capabilities that match other capabilities that are in their clouds, right? So it's into your advantage to adopt that, because usually there are more features that are coming with new versions that make your life easier, right? Running Kubernetes now is a lot different than it was 4 years ago, right? It's easier now than it was, and it's probably safe to assume that trend is going to continue.
Do you have a slide that compares to the remaining cloud service providers? You talk about their advantages versus. I just come to the point.
No, yeah, we don't. I mean, we can do that in conversations, like, when you're talking with like your account team from AWS, Nick. I keep pointing at Nick. Nick's in the hot seat for Humana, but yeah, I don't think we have any public facing stuff. It's just part of the AWS philosophy. We like to talk about our stuff, let them talk about their stuff. They're good at what they do. We're good at what we do, and let you decide, or like make your informed decision. Other questions?
This was useful.
Thank you. Yeah, and I mean, like I mentioned before, this is a super rich environment. We can go very deep in a lot of areas. I would definitely pull in experts for certain areas, right? This is but there's room to have plenty of conversations around Kubernetes and all the related things, service mesh, all those things. If you want in the future, right? So when Nick sends out the survey for topics that you guys want to talk about, don't forget to throw those in there because we can definitely schedule them.
We have more continuing sessions where we talk about AWS database and how do we deploy some kind of workshops kind of stuff.
Sure. Yeah, that's completely this meeting's for you guys. So if that's what you want to see, just put it in the survey and we'll make sure we talk about it, right? Yeah, we can talk about it here. Since you guys are at you've got AWS support, use that channel too. Lean on your AWS folks. There's a lot of they can bring experts from the team that's writing the AWS implementation of these things to talk to you guys sometimes, just whoever you want, right? So yeah, don't struggle looking for information. You can use this forum and can use your own support channels with AWS to get all the answers you need.
If you signed up on the meetup page, and they put the monthly survey out through that. So as long as you signed up for that, you'll get it. I'll try and catch up by the end of the week.
And continue this conversation at West Six. Does everyone know where it is? Follow the herd.